Good afternoon. Today's machine design EHS webinar titled Retrofitting Legacy Machinery for Safety, Navigating Risks and Regulatory Challenges, presented by Endeavor B2B and sponsored by Schmersel. Schmersel is a safety industry leader with 80 years experience in the design and manufacture of machine safety products, industrial switches, position sensors, and control accessories for a wide variety of applications, focusing on ways to protect machinery operators and maintenance personnel from recognized hazards without compromising productivity. I'm Rihanna Bag, Editor-in-Chief of Machine Design with Endeavor B2B. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during today's session, please submit to the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in our browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation. But please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. To refer a colleague to today's discussion, share it on social media, or access event resources, click the icons on the left side rail of your screen. Also, please be aware that today's session is being recorded and will be available on the Machine Design, EHS Today, and NED websites within the next 24 hours. You'll be notified by email when the archive is available. Now, I'd like to introduce today's speaker, Devin Murray, Technicum Services Manager with Schmersel USA. Devin Murray is the Technicum Services Manager, as I said, at Schmersel, with more than 15 years of experience in machine safety. A TÜV certified functional safety engineer and functional safety trainer, he has developed training programs, conducted risk assessments, and authored white papers on machine safety. Devin also holds a BSEE and MBA from Alfred University. Welcome, Devin, over to you.
Thank you so much, Rihanna, and thank you everybody for joining us on this webinar for retrofitting legacy machinery for safety. I have quite a bit of information to share with you all and within an hour time frame, so I'll jump right into it, go over what we are expecting to review today. So I want to start off with looking at why retrofitting matters. When we look at these legacy machines and we talk about retrofitting it for safety, I want to spend some time to highlight why it matters and what do we mean by a legacy piece of machinery, equipment. I then want to look into some common questions that we've been asked regarding retrofitting machinery. If it's a question that we've been asked quite a bit, it may be a question that you have, which is probably why you're on this call with us now. All right, so I want to look at some common questions and help get some of those answered, maybe before you even type those into the questions field. Then I want to look at some basic guidance to help provide you with a template or a roadmap to successfully upgrade some of these machineries with safeties. Then we'll end off with some key takeaways and a summary. As Rihanna mentioned, we should have some time at the end of this presentation for some question and answers. If there's any questions that we can't get to live, we will certainly get to you in an email. But we should have some time at the end of this for some questions. So let's jump right into the content, and I want to first again talk about why retrofitting matters. And to do that, let's first look at what do we mean by a legacy machine, right? So what do we mean? So when we look at a machine on the floor, the plant floor, right? You can walk by a machine and it looks a little old, right? And you can say, yeah, that's one of our legacy machines, right? Maybe it's a machine that has an old technology, outdated systems, looks a little bit like that. Okay, you may not have a machine on the floor that's driven by steam, but it may look a little dated, right? And we can say, yeah, we have some legacy pieces of equipment. However, maybe we have some machines on the plant floor that don't look like that. They look a little more modern, right? Like we show here some examples, but they still fall under the category of legacy equipment, okay? If you have a machine that was built, I don't know, in the 70s or the 80s, I think we all can agree that, yeah, that's probably going to fall under legacy equipment, right? But maybe you have a machine that was built in the early 2000s, right? Here we are in 2025, so maybe 25 years ago, maybe even, 2012, okay? Even 2020, that may be legacy now because that machine no longer complies with current safety standards, okay? If that machine no longer complies with the current safety standards as they are today, that may put it in the bucket of legacy equipment. And this brings in the conversation that we have today of how do we upgrade this machine to make it compliant to these current relevant safety standards, okay? When we look at that, again, we can say, yeah, we have this machine. It looks old. It's legacy. But keep in mind that even if it's one of your newer machines, if it's not compliant to the current standards, you may want to classify that as legacy equipment as well. Okay, and again, that brings in this discussion that we're going to have now. When you see the different types of equipment on your floor that may be considered legacy machinery, it can be legacy for a couple other reasons, right? Or it can be a machine that is custom built, okay? And the reason that it's being used today, if it was custom built in the 70s or 80s, is because it does the job, right? And if it's not broke, don't fix it, right? Well, maybe not so much, right? Because again, we want to have a mentality that we need to upgrade these machines for safety. And again, we're going to go into more detail why. But if it's a custom-built machine, as one of a kind, we still want to look into it to make sure that it is safe, okay? If we build off of that and say, yes, we have this unique machine that's been built maybe in-house to do this one particular task, we have to acknowledge the possibility that this unique machine poses unique hazards, right? And when we understand that, we have to go into some conversation, some risk assessments to understand what that unique hazard is, so that we have a better understanding on how to properly safeguard these hazards. Okay, you may also have a situation where the machine has been discontinued by the OEM. Right? So maybe you didn't build this machine in-house, but you bought this machine from a manufacturer, and that manufacturer maybe is out of business, okay? Or again, maybe they discontinued that model. We'll see as we progress into this presentation, when we get into some common questions and some guidance, what do we do in those instances where the OEM is no longer in business, or the model no longer exists, but we still need to bring this machine to up to par with safety. All right, so we'll discuss what we do with that and that aspect. With these legacy machines, okay, you may have situations where you are retrofitting them, and it could be for the process. Okay, so you have a machine that's been in use, and you now determine that we need to increase output, throughput, right? So we do some modifications on the automation side of it, but you don't take into account the safety side of it. And if you retrofit without safety, you do increase the possibility of introducing new hazards. Okay, so at the end of the day, the moment that you you touch this machine and you decide that you need to upgrade it for any reason, you really do need to do a risk assessment on it. And by doing so, this will help you understand what those hazards are for this machine and kind of get the ball rolling for upgrading for the safety portions of it. Right. So starting off with that risk assessment. When we look at the potential liability for not introducing safety to a legacy machine, we can look at the OSHA requirements, and I'll dive into that in a little bit. But here on this slide, I at least introduce this legal requirement that we are required to have a safe working environment. Okay, so the workplace shall be free from recognized hazards. Right, and if we are not doing that, if the workplace is not free from recognized hazards, then this is a potential liability. Okay, we need to make sure that we have a suitable, safe solution for this machine. And when we look at some possible control measures, we'll see that as we sit today within the industry for safety, there are a ton of options. And it comes down to what's the best option for this machine, for this application. Okay, but we have to realize that safety has come a long way. And I think we all can agree on that. So we really have to see what can we take from the industry today and apply it to our legacy pieces of equipment. What we see sometime, what I see sometime at least, is when a legacy piece of machinery is being upgraded for the process, sometimes there's this conversation of, you know what, yeah, we know there's some hazards here, and let's go ahead and throw on a light curtain, right? Or let's do another a hard guard here and some scanners there. But it's not based off of a risk assessment, and let's just add on some safeties. And if we start to add on solutions without going through a proper risk assessment, we may find ourselves implementing wrong solutions, which would also create a false sense of security with these, what I have here, these partial upgrades. Okay, something that again that I've seen that I definitely want to highlight, that we want to go through a proper risk assessment when we are looking at these legacy pieces of equipment. Okay. Some other factors here for why retrofitting matters. And when we look at what I have here, some key performance indicators to help us understand, do we need to go into this conversation of retrofitting and adding additional safeties to this machine that is already existing and running? Well, there's two indicators that we can look into, and they can be considered leading indicators or lagging indicators when we look at this piece of machinery. And I have here some leading indicators to understand if we need to bring in some safety to this existing legacy piece of machinery, right? And maybe you've done an internal audit, an internal assessment on the machine, and you've identified some areas of concern. Okay, and you identified that there are some hazards on this machine that your site, your company feels are not acceptable. Okay, this may be a leading indicator that we want to do some retrofitting for safety. Okay, or maybe you could look at some history with this machine, and you may indicate that there are histories of near misses. Okay, fine, we have a history of near misses. Let's take a closer look at this machine. Maybe we need to upgrade the safeties on there. On the flip side of near misses, you may have a history of, unfortunately, accidents. And we look at accidents, those are considered lagging indicators. Okay, and yes, if we have a machine where we have a history of accidents, that is a red flag, clear indication that we need to look at some safety modification. Okay, maybe also there's some machine downtime as it relates to the safety faults with this machine. Okay? Again, we're looking at legacy pieces of machinery that's been, in operation for quite some time. Maybe the guard end locks on this legacy piece of machinery, maybe the doors are starting to sag a little bit, and we are having some false trips. Right? Maybe we need to look at that. So if there's some downtime associated with the machine with the safety, again, indication that maybe we need to look at some safety retrofits on here. Okay. Once we have this understanding, perhaps, right, that maybe we do need to have some safety retrofitting on this machine that's in use, there are some questions that we tend to see, all right, that we tend to ask. And one of those questions is, who's responsible? Who's responsible for making this machine safe? And for new machines, that's not the scope of this conversation. For new machines, as an end user, you can say, well, I'm buying this machine from the manufacturer. I want to make sure that the manufacturer is going to be responsible for giving me what I need for this machine. Okay, that's a conversation that can be had. But when we look at these legacy pieces of machines that are on the floor today, whether it's 5 years, 10 years, 20 years old, the question is, who's responsible for that, right? And to answer that question, I want to bring in the OSHA General Duty Clause that I mentioned in my previous slide. And we look at the General Duty Clause. We have here is written out. Each employer shall furnish to each of the employees a place of employment which are free from recognized hazards. But I have here some highlighted terms, right? And it says each employer shall, right? So the employer shall means that you must do it, right? And what must you do? Well, you must provide a workplace that's free from recognized hazards. That's the legal requirement. If we go based off of that, we're not concerned with the manufacturer, right? The OEM is not responsible for providing a safe machine. The end user is, okay? This is the legal requirement as called up by OSHA. I also want to bring into this conversation or to this question an ANSI standard, ANSI B11.0 specifically here. This is a safety standard for the safety of machinery. Okay, this is from the American National Standards Institute. The scope of ANSI B11.0 is to provide general requirements and essentially a risk assessment process for machine safety. Inside of ANSI B11, they call out responsibilities for the supplier or the machine builder, the integrator, and the end user. Okay. For this conversation here, I want to bring in this table, which is concerned for the end user and the supplier or this machine builder, right? And this chart here, this table from ANSI B11.0 highlights the risk assessment process. And on the first 4 rows for the supplier and the user, we see that ANSI B11.0 calls out some potential collaboration for risk assessment. But what we also see on those first 4 rows, that's really for new machines. This conversation we're having now is for legacy pieces of machinery. So if we look at the user column and we look at row 5 and below, we see that once the end user owns this machine and is operating, the end user again is responsible for making sure that this machine is safe with these additional ongoing risk assessments. One of the bubbles here call out retrofit. Okay? The purpose of this conversation, the retrofit, a targeted risk assessment. that is the responsibility of the end user. Okay, so we see this from ANSI B11.0. We can interpret the general duty clause from OSHA, and it states that, okay, I own this equipment. It's on my plant floor. I'm responsible to make sure that this legacy equipment is safe. Okay, now, this does not mean that we can't go to the OEM for support. And again, I'll dive into that when I get into some basic guidance. But here, first introduction of it, it's the responsibility of the user, okay, to make this machine safe. If we build off of this, right, and you say, okay, you know what, it's my responsibility to make sure that this machine is safe, but it's a legacy piece of equipment. It's been running. It was designed 15, 20 years ago. It meets the old standards. All right, can my machine be grandfathered in? All right, this is a huge question that we get a lot, and I don't want to provide a blanket absolute yes and no, but typically it's no. Okay, we can't grandfather safety in, and I'm going to explain why. Okay, so first thing is, what's recommended when we are trying to safeguard a machine? What is recommended? Well, what's recommended is using current industrial consensus standards like ANSI B11.0 that I just mentioned. That's recommended. ANSI B11.19. If we go to the ISO standards, ISO 12100, there's a whole plethora of standards that are recommended for us to use. When we look at, and I stick for this example, ANSI, right? We look at an ANSI standard. If we open up ANSI B11.0, it will state in there that this is a voluntary standard. Right? It's not required for us to use by law, but it's in your best interest to use these ANSI standards, the ISO standards, to help you fulfill the requirement. Okay, so then the question is, okay, well, what is required? Well, what's required is to make sure that you're providing a safe working environment, right? That general duty clause. You have to make sure that you're compliant to the OSHA code of federal regulation, such as 1910.212, which are the general requirements for all machines. 1910.147, right? The control of hazardous energy or lockout tagout, right? Those are legal requirements. Also, 1910.6, incorporation by reference standards. Okay, so if OSHA references a standard under 1910.6, that is now a legal requirement, and they can cite you on that particular standard. How does this answer the question? All right, can we grandfather safety in? So we see what is recommended, consensus standards. We see what's required, right? A safe working environment, fulfilling these requirements called out by OSHA's federal regulation, code of federal regulations, right? So to answer this question about grandfather safety, I want to ask you two questions. One is, this obsolete standard, this old standard that you are trying to use for justification, does that obsolete standard address all recognized hazards and provide an acceptable means of safeguarding as required by OSHA? And does OSHA has this reference or has this standard in reference under 1910.6? Okay, if you can't answer yes to both of those, then we are not allowed to use this old standard to justify grandfathering in safety. Okay, I'll explain more in the next slide as far as OSHA is concerned with updated standards. But to me, though, this is a big misconception or a question as far as grandfathering in safety. I mean, we can't do this. This is something that we don't want to do. I mentioned as I try to answer this question, that this is not a blanket yes or no, because there's always, exceptions to the rule, right? And if we look at a standard that's incorporated by reference, it's an old standard, a very old standard. There may be a standard that's for a particular type of industrial machine or industrial equipment. Inside of that old standard, there may be, a grandfather clause in a very old ANSI standard. And if that's the case, if it's referenced by, a corporation and there's a grandfather clause in there, then yes, you can use it. But that's typically, typically not the case. Okay, let's expand that a little further. Okay, because again, that's a very common question that we get. So then the next question is, if a consensus standard if they're voluntary, right, can I use an obsolete standard during upgrade? To answer this question, I want to lean in on an OSHA letter of interpretation, and I have the link down here for the full letter. Okay, but this letter of interpretation states that a safety standard, might be used by OSHA to establish both recognition of the hazard and the existence of a feasible means of abatement. Okay, this OSHA letter also states that they can use this standard as evidence to support citations and litigation. Okay, so what does that mean for us? So if there is an updated standard, OSHA can use this latest and greatest standard for justification to say this standard calls out these recognized hazards, right? Especially if it's a standard that's related to a particular type of machine. In addition to that, they call out some means to help remediate these hazards, and they can lean on these current relevant safety standards during legal activities, right? So if they want to cite you on something, they're going to use the latest and greatest safety standards. So we have this understanding. Yeah, there's standards that we have in our library. Standards cost money, right? ANSI B11.0 for a risk assessment process. If you start to upgrade your safety functions, if you go into, ISO 13849, if you look into safe distance calculations, and all these different standards cost money. I get it, right? We all get it. But trying to, say, okay, well, we have this library of these old standards. We want to use this as we upgrade these machines to have these updated safety requirements or the safety control measures. We have to use the latest standards. Okay, and again, to answer that question, I refer back to this letter of interpretation. With that said, if we say, okay, you know what, fine, I get it. We got to use the latest and greatest standards. I just mentioned there are so many of them, right? So the next question you may have is, okay, well, which ones? Tell me which ones I need to use. To answer that question, I want to explain to you what types of standards there are within the industry, okay? So a standard can be broken into what we have here, 4 types, type A, B1, and B2, and C, okay? A type A standard is general basic safety, and that would be like what I have for ANSI B11.0. Okay, that's, again, a standard for general requirements for safety. It gives us an idea of how to do a risk assessment. That's very similar to ISO 12100, international standard. Okay, there's also a B1 standard for certain aspects of safety. I'll call out here ISO 13849. This is for performance levels. So we have a full webinar on this. If we are upgrading a machine and we want to add on a safe function, we may want to consider ISO 13849. Okay. There's also a Type B2 standards, which looks at the requirements for a safety component. So if you are wanting to use light curtains or two-hand controls or safety mats, you want to make sure that we are using those devices that meet these certain B2 standards, right? I have example here, standards for emergency stops. Okay, so ISO 13850 for here in the States, right, NFPA 79, they call out the requirements, red mushroom, yellow background, self-latching, the requirements for these stops. Lastly, there's a Type C standard. Type C standards are for a specific type of machine, right? A lathe, the mill. The examples that I have down here are for robot and robotic cells. ISO 10218, ANSI A3 R1506. I have this slide here because if we are trying to focus on what standards we need to adhere to or we want to use to fulfill our legal requirement of a safe working environment for this legacy machine, you first want to see if there is a Type C standard. All right. Does the machine you have also have a standard to help provide guidance to make it safe, like a robot, right? There's a robot standard for you. If you have a machine that was built in-house or a custom-built machine to do this one particular task, yeah, okay, there's not going to be a Type C standard for it. But that's when you rely on that Type A basic safety standard to do your general risk assessment to identify what those hazards are, so that you can help provide a safe solution. Okay, now for the Type C standards, whether it's a lathe, the mill, robot, whatever the case is, they'll tell you some general hazards that's associated with that type of machine, with that equipment. But inside of those Type C standards, they will still tell you that you need to do a risk assessment, right? Because they'll give you some common hazards for a mill or a robot, but how are you using this legacy piece of equipment, right? Do you have this machine tied in with other machines? Are you interacting with this machine in a unique way based on how you need it to run? Right? What is your process? So at the end of the day, you still need to do a risk assessment, but at least a Type C standard provides some guidance, right? It gives you a roadmap on what to look for those common hazards. Okay, so what standards do you need to focus on? Let's see if there's Type C standard, but bare minimum, we need to do our assessments, right? ANSI 11.0, ISO 12100, for example. Another question that I get quite often when we're trying to upgrade these legacy pieces of machinery is, I know I need to add a safety function on there. I keep hearing about performance levels and categories. What are those? All right, what's the difference between the two? Okay, and again, we have some webinars on this, and those are not shameless plugs. It's just providing some more information so that I can try to stay within the scope of this conversation. But we do have some webinars on categories and performance levels. But to answer this question, I pull up the definition of categories and performance levels from the standard ISO 13849. Okay, categories is a definition, right? That's the definition of categories, but essentially the categories are how we are physically wiring up the safety circuit. Okay, is it a single channel system? Is it a redundant system? Is there monitoring in there? What are we looking at for our safety circuit? That essentially is a category, and there's categories B, 1, 2, 3, and 4. Okay. Then there's performance levels, and we see here the definition for performance levels, right? Is discrete level used to specify the ability of a safety circuit, essentially, to perform a safety function under foreseeable conditions, or essentially under a fault condition. Okay. Can the safety circuit still maintain its functions in the event of a foreseeable fault? Okay. At the end of the day, the term category itself, it's obsolete, and it's one of the parameters used to determine a performance level. At the end of the day, both of these terms, though, right, they're both used to describe the reliability of this safety circuit. And again, the category is how we physically wire it up, and then the performance level, little more involved, have some calculation associated with it, but it does take into account the category. Okay. Now, you may ask, okay, well, that's a definition, and which one do I need to, follow? Okay, well, honestly, it depends on what are you trying to achieve. Okay. So yes, you already have the decision that you need to upgrade the safety portions of the safety circuit for this legacy piece of machinery. Then the question is, okay, are you trying to comply to ISO 13849? If so, yes, we need to look at performance levels, right? Some ANSI standards that we have call out performance levels. They reference ISO 13849. Okay, if we say, yeah, man, you know what, bare minimum, we have this legacy piece of machinery. We want to do the right thing, right? We want to make it safe. We say, you know what, fine, let's look at what's considered a control reliable circuit. Right? Again, this is based off of a risk assessment. That risk assessment will tell you how reliable your safety circuit needs to be based off of the hazard you're trying to guard against. Okay, so based off that risk assessment, it'll tell you, you know what, maybe we need a category 3 or 2 type of a circuit. So it really depends on what you're trying to achieve. Okay. Some guidance. Right, trying to fit a lot of information here within an hour. Okay, so some basic guidance. So those are some questions that we get asked quite often. Now I want to provide some guidance to help formulate some type of a roadmap to help complete this journey of retrofitting a legacy piece of machine. And the first thing I want to highlight that we want to develop a plan and a timeline to implement a proper solution. And what is a realistic timeline? We need to look at machine availability. So it's a legacy piece of machinery, but it's still in use. Why is it still in use? Because it's doing a particular job, right? If we didn't need it, we wouldn't run it. But we need it. That's why we're having a conversation on how do we upgrade the safety aspect of it, right? So we need to say, what's the realistic time frame for us to bring this machine offline, right? How many machines are we looking at? Is it one legacy piece of machinery that we're trying to upgrade? Are there identical legacy piece of equipment that we need to upgrade? So we need to come up with a realistic timeline, okay? Who needs to be involved in this conversation? We'll dive into that. And, how do we evaluate and measure the progress when we're trying to upgrade these legacy machines? And the first thing we want to highlight with this journey of upgrading a legacy machine is that you might want to set priorities with the greatest risk to be addressed soonest, okay? The only way to achieve this, to understand what those greatest risks are, is by doing what? A risk assessment. Right? We need to identify those risks. We need to quantify those risks. We need to estimate those risks. Okay, and again, that's not the part of this conversation. All right, the risk assessment process. But understand that we need to do this. We need to do a risk assessment. Okay, once you do that assessment, you can then prioritize. Maybe we have this one machine that has these hazards that are not acceptable to us, right? And we need to address these first. Or maybe on this one machine, okay, there is a particular hazard that we need to address immediately because this hazard is completely unacceptable for our organization. Okay, so then you can prioritize. Along those same lines, maybe there are lower risks that you can tackle that require little capital or little labor investment, right? Can we achieve safety by making a tunnel guard in-house? Okay, that's little capital, little labor investment, but fulfills maybe a safety requirement. So let's look into that. We also need to discuss who needs to be involved in this process. right? So yes, of course, health and safety, of course, right? When we look at who needs to be involved, we need to make sure that there's individuals who understand safety, right? What are those latest and greatest safety requirements? So yes, we need to have health and safety involved because they know the standards. Okay. Then the other question is, there's one thing to know the requirements, and then there's another thing to know the machine, right? We need to know how individuals are interacting with this machine. This is huge. So we need to make sure we have engineers, technicians, operators, everyone who actually touch the machine and interact with it. We need their input. They need to be involved in this process for retrofitting safety into the legacy machine. Crucial, okay? We also have their supervisors and management. Okay, maybe they're not, interacting with this machine, but they are interacting with the people, right? And if we can have safety driven from the top down, so that we can create that safety culture, that's going to be huge in making sure that this retrofitting of a legacy machine holds. Okay, I quite often see that mentality of this is how we've always ran this machine, right? There's nothing wrong with it. I've ran this machine for 30, 40 years, and I've never seen an accident, right? And that's, of course, the wrong mentality to have. But we want to have everybody involved so we can have those discussions. Some of it comes with education. Why are we doing the assessment? Why are we now saying this machine is unsafe? That comes with communication and education. My colleague Peter did a series of webinars on trying to create a safe working culture, right? A safe culture. So again, some things to consider here. When we look at this process, again, some more guidance. When we're trying to design and integrate the right solution for the machine, we want to make sure that there's a balance between safety and productivity, and one cannot be sacrificed for the other. Okay, this is coming from a safety consultant here, right? We understand that if we prioritize productivity, maybe we're not going to provide the right safe solution. Okay, and if we prioritize safety and sacrifice productivity, then we increase the chances of what? Bypassing, right? We don't have operator input. We don't have maintenance input. And we say, yes, safety is our number one priority. So we focus completely on safety, and we don't consider, the process. We raise that chances of that safety solution that we are trying to implement. Number one, may not be the correct one. And number two, we do raise the chances of that being bypassed. Now, just because an operator was not involved or maintenance was not involved in the process does not mean that they have the right to bypass. Of course not. But it does raise the chances of it happening. And it could be because what we're trying to implement for a solution just isn't the right solution. Okay? You also need to discuss who's going to design and apply these control measures. Is that something that you can do in-house? Do you have the resources, the capabilities to do it? If it's a tunnel guard, yeah, maybe we can fabricate a tunnel guard and slap it on. Or is this a little more involved? Right? Are we integrating safety PLCs and programming and rewiring the entire safety functions? Do we need to bring in some outside help? These are discussions that you need to have. You need to make tough design reviews and milestones, right? We need to evaluate the progress that we're doing. And if we look at the milestones, okay, well, the risk assessment, that's a milestone. We've identified the hazards and risks. We maybe developed some ideas for possible solutions because we've spoken to operators and maintenance and technicians, right? We selected the components. We've done the calculations for the performance levels, right? These are milestones, and maybe we want to set those up for for the reviews as we continue on with the design of these safety functions. You want to validate, right? You need to prove that what you are designing for this safety system actually works, right? If this is a multiple legacy machines, they are identical. You want to prove out that first system, and if it works, fine. Maybe we can more or less copy and paste for the other machines, but we want to prove it out. Make sure that it works. Okay. Missing schematics. Okay. Again, this is kind of guidance and also one of the common questions that we get, right, as far as schematics. When we're trying to upgrade legacy machinery, we need to know, you need to know what's on there now, okay? And if it's an old piece of machinery, the schematics may have been lost, it may have been misplaced. If there were some modifications that were done previously, right, were those modifications captured correctly? Okay, maybe you have a senior engineer on staff who's great. They know the machine inside and out, and maybe you were being proactive and you identified a hazard, and you asked senior maintenance to develop a solution, and they took a napkin, right, and drew out a safety circuit, installed it, and perfect, everything works fine. Do you have the actual schematics? Okay, not having schematics is a hazard, right? And if you're on the call right now, we're talking about legacy machines, and you might be shaking your head like, yeah, we don't have schematics. Nope, that you're probably not the only one shaking your head, right? This is a common issue, especially for legacy machines. Now, okay, fine, that's a problem. What do we do? So first thing is, call the OEM, right? Check with them to see if they have the schematics. If not, then you will have to do some reverse engineering. Okay. Again, some guidance. Maybe you have some safety functions on the machine now, but they're being ran through a non-safe PLC. That's very common, especially for those legacy machines. We cannot have a standard PLC be used to initiate these safe functions, right? These non-safe PLCs, they lack redundancy. They lack the requirements that a safety PLC meets with those type B2 safety standards, right? Safety PLCs, they must meet certain stringent requirements both for the hardware and the software. So what we typically have to do is take those safety functions, right, and tie them to maybe just a general purpose safety controller, and then have that general purpose safety controller still communicate with that existing PLC, but we want to make sure that this general purpose safety controller is the logic device that's responsible for triggering the safe stop. Okay, this is very common, very common. Along those lines, okay, you want to develop a safe solution what you can integrate seamlessly into the current system and have there if possible, right? You want to strive for safety without compromising productivity. So maybe you say, yeah, you know what, we want to use the latest and greatest components in the industry, okay? However, we must consider the fact that maybe these light curtains and these safety PLCs, they may not integrate well with this legacy piece of equipment. Okay, that is possible. Now, that does not mean that we cannot achieve the highest level of safety. Okay, so yes, we can still utilize those well-tried electrical, mechanical components, those limit switches, those non-contact sensors, and still meet performance level E, PLE, still 3. Okay, that's also, I believe, a misconception that we can't use those, quote unquote, dated technologies to meet the highest level of safety as called out in today's standards, and that's not true. You have to take some additional considerations, some additional steps, but yes, you can definitely use those electromechanical devices and meet the performance level E, still 3 ratings. Um, Once you have a solution in place, you have to verify and validate, right? Did you develop the right solution? You do your wire checks, your performance level calculations if you're trying to achieve, 13849. Um, does does the measures actually reduce the risk? So you do a post risk assessment, right, to make sure that no new hazards were no new hazards were introduced, and that the hazard that you originally identified is now at an acceptable level, right? Do your validation, which are your test procedures. You want to make sure you update, maintain machine documentation, right? Update those schematics, update those SOPs as we introduce these new safety functions to the legacy pieces of equipment, right? Your management of change documentation. Along those lines of SOPs, make sure that the personnel, the operators are trained to these new controls and procedures, right? Okay. Takeaway and summary. So this is not a traditional conclusion because I'm going to give you some more information as I do my takeaway and summary. But we should still have some time for some Q&A, right? So some takeaways in the summary here. Safety cannot be grandfathered in. Okay, let's say that. Okay, we have to look at latest and greatest safety requirements. All right, let's look at that. Retrofitting may have a better return on investment than a new purchase. Of course, it can be the other way around, of course, but let's do our assessment. Let's develop some solutions. Let's see, because there are many times, where it is more cost effective to upgrade an existing line than to buy a whole new machine, of course. Limited documentation, outdated controls, physical constraints as far as not being able to utilize, a light curtain, for example. These are some common challenges that we see when trying to retrofit a legacy piece of machinery. Can those existing controls on this machine that was built in the 80s, can that take, a PMP output from a light curtain? That we have to examine that. Updated safety controls should be designed based off updated safety standards. Going back to some of my previous conversations we had about OSHA and that interpretation letter, right? Retrofitting may extend the service life of the machine. And so maybe instead of, hitting the E-stop, right, we have some door locks on there that provide some a coasting to bring the machine to a safe state, bring things to a home position. So maybe that extends the life of the machine instead of abrupt stops all the time. And you want to make sure that you include personnel who interact with the machine when developing solutions. Right? That's crucial. Last slide, then we get into some questions. If I can leave you with the roadmap for retrofitting, machinery with safety. First thing is identify and prioritize legacy equipment. Right? So maybe you list all machines that are 10 to 15 years old or lacking documentation, and then prioritize based off of injury history or operational criticality. How important is it to have this machine up and running? Risk potential. That's all based off of a risk assessment. Right? So you want to perform your preliminary risk assessment once you identify these legacy machines. Review how machines are being used, doing normal operations, setup, maintenance, cleaning, identify those hazards, estimate those hazards. Define the safety objectives. What are you trying to achieve? Yes, we have the OSHA requirements. Do you have internal safety requirements from your company as far as what you need to fulfill for your safety? Yeah, are you trying to fulfill ISO 13849? Design the retrofit strategy. Choose whether to upgrade or replace or add safeguarding components. Okay, what are you trying to integrate to this machine? Interlocks, light curtains, like electromechanical interlocks, light curtain scanners, safety mats. What are you trying to do? Don't forget about lockout tagout. Okay, so maybe you go through this entire process for this legacy machine, and you determine that we can't introduce these newer technologies, and maybe you go through this exercise and say, you know what, these hazards are not acceptable for us, and it turns out we can do this under lockout tagout. This is not a normal operation, right? Maybe this falls under lockout tagout. That could be a discussion as well. You integrate your safety controls, right? Use safety relays or safety PLCs for redundancy, validate or verify and validate. Okay, make sure that you have what you need for your safety components. Train your personnel. You're adding safety functions. You're adding something new. We want to make sure operators know how to reset the system once they interrupt the light curtain, for example, or how to recover from a fault from a light curtain. Like, we need to train personnel. Document and maintain. Update those manuals. Update those schematics. Right? I said that a few times because that is that's a problem, right? Update those schematics. Update those training records. And then this is not one and done. Basically, you want to make sure that you audit and you continuously improve. Schedule those periodic safety audits, whether it's annually or of course during any major changes. Investigate those near misses, right, for lessons learned. Okay. We have time. Hopefully I didn't rush through that. I wanted to make sure we had some questions. Again, this is recorded. If you need to go back, but definitely want to bring some questions into the conversation. Okay. So I'll bring Rihanna back in to see if there's any questions that we can answer in this time we have left.
I just came off mute. Hi. Yes, there are a bunch of questions. A few people have already in Devon. I'm going to challenge you. There are some really good ones under us. So as a reminder to those who have not submit a question, type your question. The question we need the submit button, and also please stay until the end of the survey, which will pop up on your screen. You can preview questions now. Survey icon on the left side rail. Okay, let's go ahead and jump into the first question. Devon, let's start with this one. How do you know when it's time to rain?
Okay. So your audio is going in and out, but let me pull up the question. I heard the first part of the question, so let me look for that question really quick.
I'll repeat it in case it sounds well. How do you know when it's time to retrofit a machine?
Perfect. Okay, so how do you know when it's time to retrofit an older machine? Perfect. So honestly, the first step is to do that risk assessment, right? How do you know when it's time to retrofit a machine? Do that assessment. I mentioned some of those KPIs earlier in the presentation. Near misses, accidents, knowing that machine is out of date, right? That's when it's time to start these upgrades for the machines, so that you can bring it up to par with safety. Right? So how do you know when it's time to update an old machine? Let's look at what safety standards they may have adhered to years ago. But again, also, are there accidents, near misses, based off your risk assessment? Are there hazards that you need to address today? Okay.
All right. Use make when retrofitting.
How do you know when it's time to retrofit?
No, the question here is, sorry, what are some of the common mistakes people are retrofitting?
Perfect. Okay, what are some of the common mistakes people make when retrofitting? Probably one of the biggest ones I've seen is identifying that there's a hazard and then just slapping on a safety device like a light curtain, for example, without the proper assessment, without the the proper considerations for safe distance calculations. Can this machine actually stop at enough time when we interrupt the light curtain? And also, it's the personnel not having the feedback from the people that actually use the machine. That is a critical step in trying to provide a proper solution for retrofitting, I would say.
Devon, if the OEM is performing the retrofit, are they required to perform a fall on the end user?
Let me see if I can find that question. You broke up. You broke up again. Sorry. Okay, perfect. If the OEM is performing a retrofit, are they required to perform a risk assessment, or does this still fall on the end user? Perfect. Okay, so if the OEM is performing a retrofit, ideally you want to have that collaboration between the OEM and the end user to do the risk assessment. Okay, if the OEM is going to do the risk assessment on their own, fine. Okay, as long as they have a process to show they're reasonable for foreseeable hazards and remediations. If the end user signs up on that, right? At the end of the day, it's up to the end user to provide a safe working environment. That's why ANSI B11.0 calls out that true need for a collaboration. So to answer that question, it ideally is both the OEM and the end user. But at the end of the day, yes, the OEM can do it themselves, and then it'll be up to the end user to say, yes, this is acceptable for us. Hopefully that answers that question.
Devin, this year is I'm going down to question number 16 in case you're following along. Would you recommend redoing the risk assessment as part of an audit, or would the audit be more of a spot check, which could trigger redoing or revising the risk assessment?
Perfect. Okay, so yeah, so really an audit, as long as we are not moving the machine, updating the machine, we're not touching the machine as far as the process goes, we're not doing anything with the machine, then yes, we can do what you call here an audit. Okay, simple audit just to see how we're doing with this machine. Anything other than an audit, if we move this machine, the minute that we lift the machine off the ground, we're changing the process, we're changing how we interact with the machine. This triggers a full-blown risk assessment. But if nothing's changed since last year, 2 years ago, or nothing's changed, then yeah, we can rely on a simple audit, like you mentioned, a spot check. Okay.
Devin, thank you so much. We have a bunch more questions, but we are actually at time. So I'm going to just suggest for those questions that we haven't had time to answer, we can certainly get back to our audiences via email. And so this concludes today's presentation. On behalf of Machine Design, EHS Today, and NED and Endeavor B2B, I'd like to thank Devin Murray for speaking and Schmerzel for sponsoring today's event. And of course, all of you for joining. Don't forget to take our exit survey that will pop up on the screen at the end of the webinar. Have a great rest of your day.
Thank you, everybody.